In this video, we are going to solve exponential equations. An exponential equation is named as such because the variable that needs to be solved is in the exponent. In grade 9, you were taught how to approach these type of equations, and I'm quickly going to give you a recap. Your main aim is to get one base on each side of the equation and to ensure that those bases are the same. This is usually done by writing the bases in terms of prime factors. When these bases are the same, you can make the conclusion that the exponents also have to be the same, and once you've done that, you can solve x. In our example, the left-hand side is already one base, which is also a prime number, but on the right, I'm going to rewrite the 32 as 2 to the power of 5. Because the base on each side of the equation is the same, the exponent on the left has to be equal to the exponent on the right, which means I can equate the two exponents. And that means that x is equal to 5. From here onwards, we are going to add the knowledge that you gained in video 2 and 3 to work on bigger equations. In example 1, we have our variable in the exponent, but on the left-hand side of the equation, we have two numbers in the base. I'm going to keep the 27 to the power of x minus 2 just like that, and divide the right-hand side by 12. This 4 over 12 can then be simplified to a third. Next, I want the base on each side to be the same. So I'm going to rewrite the 27 in terms of prime factors as 3 to the power of 3, which is still to the power of x minus 2. And on the right-hand side, I'm going to use exponential definitions to rewrite a third as 3 to the power of negative 1. Next, I can use an exponential law to simplify the left-hand side by multiplying the exponents. And once I've done that, I now have the same base on each side of the equation. Therefore, I can now take the exponent on the left and equate it to the one on the right. Now we have a normal linear equation, and I'm going to start off by adding 6 on the right to get a positive 5. And then I can divide by 3 to get a final answer of 5 over 3. In example 2, we're going to make use of some knowledge that you gained in video 2. If you want to go and have a look at that again, you can follow the link in the description. On the left-hand side, we once again have two base numbers that are multiplied together. But in this case, it won't help us to divide by one of them on the right-hand side, because then we separate our variables. Here, it will be more useful to simplify the left-hand side until we have one base. And for that, we'll change the bases to prime factors, so the 3 will stay like that, and 9 will be 3 to the power of 2 to the power of x minus 1. On the right, I will also change the 81 into prime factors as 3 to the power of 4. The left-hand side can now be simplified further by multiplying the 2 exponent with x and minus 1. And now I can finally change the left-hand side to one base by adding up the exponents that we have. Therefore, I will have to the power of 3x minus 2. Now I finally have one base on each side, and they are the same. So that means the exponent on the left is also equal to the exponent on the right, and I can solve x. So x will be 2. In example 3, we now have two terms on the left-hand side of our equation. So if you need some more information about this, you can go and watch video 3 again. We now need to make a plan to change the left-hand side to one term. And to do that, I'm going to start off by breaking up the first term and giving each exponent its own base. To change the left-hand side into one term, I'm going to take out a common factor of 5 to the power of x, and we'll have left 5 to the power of 1 minus 2. That bracket can now be simplified to multiplied by 3. Up to now, we've been simplifying the left-hand side. Now we can start solving the equation. So I'm going to get rid of the 3 by dividing both sides by 3, and then I will have 25 on the right. Next, I want to get the bases the same, so I'm going to change 25 to 5 to the power of 2. And because the two bases are the same, I can now also say that the exponent on the left is equal to the exponent on the right.